I will start first with the constraints and challenges of SHM in aeronautics. What in aerospace industry will face will be the limited fuel consumption, because you have to reduce the environmental footprint. The challenge of very good power over mass ratio, which means that if you have the SHM system new part installation, it shouldn't weight more than the former part to not impact the weight, total weight. What is linked to any new technology, the risk linked to the maturity and certification concerns. And the SHM should not only be for diagnostic, but also for life extension due to its integration. And it shouldn't have any or less impact on the mean time before and schedule removal. You know, the schedule removal are the main issue for the air traffic and the airline industry. The constraints, if you look at the detail, will be the size, the dimension of the system should fit on the available space or volume, because we don't have a lot of volume and space on these structures. Any additional weight will impact the fuel consumption, so the payload is a very big issue. You also have to care about the power consumption, and you have to minimize the system consumption. And of course, the cost, the final criteria is the impact on physical dimension, and we should be evaluated, and the cost-benefit analysis has to be done, considering the additional weight or the additional services. The main concern, the new equipment compared to the former one. It has to be at least as reliable as the former equipment, even with added system. You should be able to assess damage and manage the usage. The weight should not be more, and the consumption should not increase. And approximately the same or even lower cost, which we have this what we call the swap plus C, size, weight, and power consideration reduction, and also the cost concern. Once we have seen that, it means that we have to think about new paradigm. What is this new paradigm is about? As I said, the SHM will not be only about health monitoring. It should be also for health management, meaning that you have to take into account the damage, the fatigue, the load assessment. This damage benefit has to come from new technologies, additive manufacturing, surface functionalization, which is something we are doing in MORPHO, like embedding SHM and sensor network. The collaborative network coming from the industrial Internet of Things, even the augmented reality for HMI, human-machine interfaces, a need for collaboration between them, and the artificial intelligence and model-based with that data analysis and prognostics. And this move to the damage awareness, the remaining useful life with prognostic, and even more damage-tolerant equipment. So you have to go for a global system approach, because if you look at each OEM, they may have individual or several SHM systems. The aircraft may have his own SHM system, meaning for the airline that you have multiple SHM systems. How can you manage that? Because you have the concern about interoperability, have a global system optimization concern, the size, weight, power, cost, and the decision to make. And the last but not least, the data and the ownership of the data, because we all know that data is the heart of the business, will be the heart of the business, and for the services and the responsibility and knowing for owning this data. So there is a need for a global system approach. There is a good, very high interest of collaborative work within stakeholders. What's the interest of collaborative approach between stakeholders? You can discuss about the constraint allocation or how you share this allocation. You may share some need or sharing of components and how you share the data and useful information. So as OEM, you have to deal with aircraft manufacturer, with airlines, and maintenance operator. This means that with the maintenance operator, you have to discuss about the integration, think about partnering and teaming with airlines or intimacy alliance with aircraft companies. So if you look at the history, there is a move from health monitoring to health management. We start with for us, it's SHM, like structure health monitoring or management. Then there's a system health management, which moved to integrated system management or integrated vehicle health management. This integrated system or vehicle health management is a capability of the system to assess the current or future states of the system or subsystem health and how to integrate this in the global picture of the system health within the available resources and operation demand. So the aims of this SHM or ISHM or IVHM is to enable better management of the system or the vehicle fleet health, meaning that you have to improve safety through the use of diagnostic and prognostic to fix fault before they come to an issue, to improve the availability through the better maintenance scheduling, improve the reliability also, because you have to get more understanding of the current health of the system and base your maintenance on the policy you can propose. And at the end is to reduce the total global owning cost through the reduction of unnecessary maintenance and to avoid and schedule maintenance. And this is an example coming from the literature that if you look at what they describe as integrated vehicle health management is a global view. You start with the design, engineering, then the manufacturing with all the topics, the production, certification, and testing, the total ownership cost, the requirement, the failure analysis, the design model, the system test data. In operation, that you have the sensing, you acquire data, you transfer them to analysis, you make an assessment on the health status, the current and the predicted one. And then you can go back to the operation and give some recommendation for the operational scheduling or the operational effectiveness, or to predict the maintenance and prepare the logistic. And this can be also go back down at the end, be able to go to the design to have a loop, the global loop on the system. So what will be the added value, or what are we seeing as the additional potential value? If you listen to the voice of customer, there are different customers at different level. You have the aircraft and the airlines. They want to reduce the operational interruption. There is a life cost reduction for the whole air traffic. The travelers, as like you and me, we want to travel very in the safe condition and also low cost, if possible. And there is a public opinion about the greener traffic, the concern about the environment impact. The aviation market forecast is very old, the market forecast, but it doesn't change a lot, meaning that we have the different airplane delivery by region, North America, Europe, and Asia Pacific. You can see that Asia Pacific is most important, but this market value is about 6.6 trillion, and the traffic growth was expected to be by 5%, and the fleet 3.5%. In 2016, was around 28,000 commercial aircraft carrying 3.5 billion passengers. This number was expected to double by 2026 to a total of 40,000 aircraft carrying 7 billion passengers. Then COVID happened, 99. So it's just a delayed situation. It will happen not in 2026, perhaps 2030 or later. So you have to still guaranteeing the safety and worthiness of this aircraft, maintenance, repair overall, which is a necessity. The estimated value of this global aircraft maintenance repair overall market is about 67 billion and still growing, and is responsible of 35 to 40% of the airline maintenance cost. So engine MRO is dominating the market. So if you look at the average turnaround time for the engine, it's estimated to be 60 days with up to 50% of additional deviation. It means that when you come to the aircraft comes to the gate, the ground support has to be to get the aircraft checked, clean, refueled, unloaded, reloaded, and ready for next flight. You all see that when you're at the airport, you have to, especially for the short and middle range traffic. This deviation mainly depends on the diagnostic stage duration. So it means that if you have early stage and automated health assessment and prognostic, this will highly contribute to reduce the turnaround time and this deviation. And this also have a direct impact on the competitiveness of MRO companies and to reduce the maintenance time, of course. And at the end, direct impact on the airliner operation cost too. So the OEM market, we have to increase our aftermarket presence, meaning that you have to think about the market share for the newest generation of aircraft. You have to think about new repair capabilities. It's necessary to make decision for entering new market for each airframe, engine, or component repairs. We need less maintenance with health monitoring or management, and predictive maintenance will help to reduce the overall time on tool requirement for individual checks with fewer repairs. And of course, the use of data analytics will increase. So we have critical new source of value to the aftermarket driven by those who design the best algorithm and most rigorous data management. How many minutes I still have?
Many.
Many, okay.
Not many.
Not many, okay.
Yeah.
So continue on the potential value. You have the significant reduction of maintenance cost and increase of aircraft availability. You have to develop probabilistic SHM data driving methodologies. What I'm saying that is most have done on our project, yeah. That's what the topic addressed in the MORPHO project. So you have to need methodologies for damage assessment as well for the remaining useful life. What you qualify the use of embedded sensors or embedded sensor network for the assessment of life cycle of the component and system. And this will enable for a new inspection strategy of this component based on automatic system or technology. Of course, we have to pay attention to the ecology aspect and recycling, total or partial recovering of the material used. We are working on developing the new technology to optimize disassembling and recycling of components after their end of service life. And of course, the qualification standards and certification concern is very important. It has the adoption of standard for embedded lifecycle management. So there are something we are proposing guidelines or work on new guidelines and standard for the certification and implementation of the innovative manufacturing process, and also for the implementation of SHM system. So going for the concluding remark. MRO to support maintenance, moving to support maintenance and services. But 4 main topics. Ensure and maintain operational excellence for customers, meaning that increase the capacity for maintenance forecast and schedule. Have really to improve this aspect. We need to be more efficient, to have more efficient means for assistance, troubleshooting, inspection, and to provide more efficient maintenance operation, reduction of turnaround time, repair, logistic, etc. You have to bring maintenance requirement to design level for new equipment and system. So we need to learn more from experience in operation to include support and maintenance system requirements at design level. Third topic, support equipment and system performance in operation in their environment and taking care of airworthiness. This means that we have to maintain and increase the same level of performance during the operation life cycle. Reduce the environmental footprint, which is a very huge concern, especially for maintenance operation, how to replacement or versus reparation, new processes to develop or to settle, and how to recycle parts or components. And value will come from increasing maintenance associated service revenue and margin, of course. We have to think about new service to develop or around this technology, SHM as technology to improve to propose new services, to improve competitiveness of maintenance and shop repair, and also the spare forecast. And the main leverage for that will be digital transformation based on the cyber physical system to help for a better collaboration between computational entities or sensor technology that allow to generate this data. Some will call it a digital twin, but it could be, you have many different definitions of digital twin. So you have to commit on what is the right definition. So there's still room for innovation. I'm talking to academics and researchers, most of the audience. It will be enjoying technology and damage diagnostic for aircraft equipment and system with high potential to offer substantial benefits to reduce weight, but keeping faster, leaner integration and repair. Advanced quality monitoring and online process control will help also, and we should be applied to flexible automation of manufacturing, also for maintenance and repair process to help to have a better rates. The manufacturing process for the production of multifunctional and smart parting system. This will cover the whole production chain with a view on the to support activities such as supervision during operation and during manufacturing. Sorry. So the integrated technology and methodologies will bring us to the next generation health management and monitoring with the global sensor development, wireless network, data-driven fault detection, and new MRO and recycling technology for these multifunctional and smart parts is really necessary. And at the end, you have to tackle standardization or certification also, and developing the best practice for guideline and processes for the certification and engine component assembly with what we may call the simulation assist certification issue. So I want to finish to conclude my talk with the document I found lately. What is the evolution of SHM concept? We have I didn't know that the SHM started in 1960. They started talking about SHM. Then they moved to vehicle health monitoring, 1970s. The integrated vehicle health management was the 1980s. The integrated system health monitoring, 1990. Prognostic and health management, 20. And then 2020, there was integrated system health management. And this is moving what they call intelligent health and mission management. So you have what they propose here is while the SHM includes enhancing the maintainability, reliability, safety, and performance of system, the next evolution, which is the intelligent health and mission management, will delve deeper in the utilization of online system health prediction to modify mission profile to ensure safety and reliability as well as efficiency through predictive integrity. I want to conclude on that.